So today we're just going to go over really fast some like ultra basic predicting of a couple types of reactions. Now, what does it mean to predict a chemical reaction? Well, so far we've balanced chemical reactions where you've put the coefficients in front of them. We have also identified the different types of reactions. But now what we're going to do is actually go through and predict the different types of reactions, meaning that you're going to be given some reactants. That's the stuff on the left side. So you're going to be given something like this. It'll just be like, you'll be told something really simple. So it'll be like A plus B, and then you're going to have to tell me, like, for once. You're going to have to actually say, like, what's over here. You're not going to be given this. You're going to have to figure out the reactants. Like, all right, so predicting reactions. And again, that is going to involve you figuring out what are the reactants. Or, pardon, what are the products? That makes more sense. All right, so that's the job. That's like your job. So what I'm going to show you today are three reasonably simple ones. This is just kind of review, or not review, but this is just it's like this is not going to be super focused on. That's why we're just going to talk about it for a few minutes. All right. Instead, we're going to spend a lot more time on the two specific types for the next few weeks. So these are just sort of more general things that we'll refer to a little bit. So the first type of reaction that we're going to look at is synthesis. So how to predict a basic synthesis reaction. Really simple. Let's look at a really simple synthesis reaction. So it's going to be Na plus Cl2 plus chlorine gas. So solid sodium plus chlorine gas. I'm not going to bother with phases though, because that we're just keeping it simple. So first, you got to look at this reaction. You're going to be like, okay, this is a synthesis reaction. How do I know it's a synthesis reaction? Well, I know that the only possible thing that can happen here is that these things combine. That's it. There's nothing else that can happen. So sodium is going to combine with chlorine. I mean, there's just nothing else that can happen. Sodium combines with chlorine. All right, cool. Now, as far as writing this formula, like this is where like all the formula writing and stuff matters. Like you got to think like, okay, sodium. We know this formula, obviously sodium chloride, you know it, but to be official, sodium has a positive 1 charge, chlorine has a minus 1 charge. They're ionics. When you crisscross them, it's a 1-to-1 ratio, so it's just NaCl. So you've predicted this reaction. I mean, you just went from having reactants, you predicted the product. I mean, but the synthesis usually is really simple. Just stuff combines together to form a product. There's not much to it beyond that, and that's all you'll be expected to do in this class. All right, there is a little bit more to it sometimes, like another example, something like magnesium plus oxygen. All right, this produces MgO. So you would be told, you would just be shown this, and you would have to figure out this. Now, in this case, Mg is plus 2, oxygen is minus 2. So you're going to crisscross those, and it ends up being a 2-to-2 ratio, which you then simplify to a 1-to-1 ratio, which is why you just write MgO. All right, but again, synthesis reactions predicted. You would want to go back and balance these, so you would put like a 2 here and a 2 there. This one, pretty much the exact same setup. I mean, they're all reasonably simple, especially the ones you would see in this class again. All right, next. The other type of thing that we might look at is a decomposition reaction. Remember, that is when you have something breaking apart. All right, that is when you have something breaking apart. A good example that we could look at is iron oxide. So again, decomposition is really easy to spot because all it is just simply one reactant, and it's like, all right, what am I putting over here? Like, you're given one thing, and so clearly the only thing that can happen is they're going to break apart. Now, how do things break apart? Well, I will show you in a second. All right, so sorry I had to pause for a second, which to you is no pause at all because it's instantaneous. Whatever. So we're going to talk about decomposition here. Now, decomposition. This is just when you have reactants, remember, splitting apart. And the only way this can split apart is it can break that bond in the middle. There's nothing else that it can do. That's the only option you got. All right. I mean, you could maybe potentially lose one oxygen or something, but we're going to keep it really simple again for you. There's not going to be complex decomposition reactions where you have one thing breaking apart into multiple non-obvious compounds. All right, there are some rules that we could follow and all that, but again, just for the sake of online school, we're going to keep it really simple. So we're just going to break these apart. Well, we're going to separate the cation and the anion, so the positive ion and the negative ion. We're just going to separate them. All right. Now, to do that, you'll just write them over here. So you'll write iron plus, and then remember oxygen. This is the part that confuses people. Oxygen, when it is by itself, it's a diatomic element. Remember the diatomic elements. There are 7 of them. All right, there are 7 diatomic elements, and those 7 diatomic elements are always going to be written. See what I have written down somewhere. So those 7 diatomic elements, when they're by themselves, are always written with a subscript of 2. So we've got all of these. They make a nice little 7 there, actually, but then you also need to include hydrogen. So this is just another reminder. Whenever you have NOFClBri or H, you always must write them with a subscript of 2 when they're by themselves. This is not a 2 over here because it's bonded to iron. It's in a formula. You got to do the ratio and everything. But over here, it's a 2 because it's by itself. All right, important to remember. So now, once you've got this, you would go back and you would balance it again. And you've balanced this reaction actually before in class already. So you would put a 3 here, you would put a 2 here, and you would put a 4 here. But again, that's just basic decomposition. And then finally, last but not least, we have combustion reactions. These are fire. These are the combustion of hydrocarbons. All right. Now, these reactions are these can be, they're hard to balance, but they're very, very, very easy to spot and recognize. So you're just going to have a hydrocarbon. That's some amount of carbon and hydrogen, all right, and that will combine with oxygen. So if you ever see a reaction that looks like this, all right, if you ever see a reaction that looks like this, all right, that is a combustion reaction every single time, always automatically. And the nice thing about these, the combustion reactions, it's really easy to predict them because all you have to do, remember, so in a combustion reaction, the products, that is the things that are made, again, are always, we know this, H2O plus CO2. Water vapor, when you burn natural gas, anything like that, let's think of like natural gas, you light your stove, the products are going to be, the actual chemical reactants that are given off it's water vapor and carbon dioxide gas. I know it seems kind of weird, you're like, fire, how does it make water? But it does. But it's not really liquid water like your thing, it's just like water vapor. So, you look at these, and then your products again, which is H2O plus CO2. So all you have to do, you just write those over there. And it can be CO2 plus H2O. It doesn't actually matter which one's first and which one's second. You just, it's the same thing. Like there's no difference. It doesn't matter. Then you'd have to go back and you'd have to balance it. And then balancing these, actually, this can be quite a frustrating thing. So you would have to go and balance them, and sorry, I was just checking that. You would have to go back and balance them, and you'd have to make sure that like everything works out. Now these can be very frustrating to balance. All right, very frustrating to balance, and I understand that. So for the sake of this, I will just show you. So this would be an 8, if I remember correctly. I know that this one's an 8. So, but this guess and check to go through. So this would be 8 times 2, 16. Over here we would have, we have 12, so 6. I think this would then be 5. Yeah. So again, that's just, I know that one off the top of my head. But again, this is an example of a combustion reaction. So you will have so you'll have like basically C random number, H random number, though they're not really random, but just, these can be any numbers, plus O2. You're always going to be, if you see something like that, you're always writing one of these things as the products. Always. Always. So that's how you predict synthesis. sometimes called combination reactions, decomposition, and combustion.